One of the compelling reasons to choose a silicone is because they have superior stability over a wide range of temperatures compared to organics. In this video, we will show you what happens at both temperature extremes in some applications that require that capability. Plastics and elastomers have a point where they become hard and often brittle. This is called the glass transition temperature, or TG. Epoxies, most acrylics and plastics, are only useful when they are rigid, hard, and strong, which is below their TG. Elastomers are used above their TG where they are softer and very flexible. If plastics are heated above their TG, they will soften, deform, melt, and eventually decompose. The upper temperature use limit for thermoplastics is called their softening point, which may occur even below their actual glass transition temperature. This may happen at a specific temperature or over a broader range of temperatures. A common thermoplastic used in electronics is acrylic. Many acrylics will begin to soften above 85°C. When thermoset materials are heated, they may soften somewhat, but they will not melt. Instead, their properties degrade as they oxidize in air, becoming stiff and brittle. Eventually, the materials smell burnt or form a char. This degradation may not have a specific temperature at which it starts, but will be slower at lower temperatures and faster at higher temperatures. Silicones have a very high thermal stability compared to most other polymeric materials. A side-by-side thermal analysis will show silicones have significantly higher thermal stability compared to their organic counterparts. There are no rules on how to show high temperature stability on a product technical data sheet. An upper use temperature is shown, but a TDS rarely shows for how long a material can be held at that temperature, or what property changes occur. Some competitor TDSs state conservative temperature limits, and some may exaggerate stability. For more information on understanding technical data sheets, see our tutorial on TDS interpretation. At Dow, many of our TDS upper temperature limits are based on UL relative temperature limit testing and represent an expected 10-year life at that temperature while maintaining at least half of the product's original properties. For silicones, this typically means retention of at least half of the original elongation. Actual use life may be longer than 10 years, depending on application requirements. If shorter exposure times are needed, the use temperature can go substantially higher. Applications that may require very high temperature stability include on or near internal combustion engine electronics, automotive brakes, ovens, cook stoves, high temperature piping which have embedded electronics, military, and many others. That covers high temperature thermal stability. Earlier we said that elastomers, stretchy rubbery materials, are always used above their TG. If an elastomer is cooled to below its TG, it will become hard and brittle. Low temperature use limits are often set based on the elongation or flexibility of a material. Suppliers use an elastomer's glass transition temperature as the lowest use temperature. For most materials, this will be from -20°C to room temperature or even somewhat higher. Silicones have a true TG of around -115°C. Few materials can reach these cold temperatures. This super low TG allows silicones to be used even in cryogenic applications. When you take a material below its TG, it becomes hard and inflexible. This is fully reversible. Once it warms above its TG, the original properties should fully restore. While the true TG is around -115°C, most silicones turn from soft rubbers into harder rubbers around -45°C. This is commonly mistaken as the glass transition temperature. Although silicone gels will become somewhat brittle at this temperature, all other silicones just become harder rubbers. Many customers can continue to use standard silicones even below -45°C, since they remain elastomeric and stretchy. Dow makes special silicones that can be used below -45°C without showing the stiffening. You can find low temperature capable offerings in our product selector guide. Applications that may need extra low temperature performance include some automotive, military, aerospace, and cryogenic uses. In this video, we discussed materials' behavior at temperature extremes. Silicones can be used at both high and low temperature extremes, all in one product. No other elastomers have this breadth of use. The properties of silicones tend to change much less than other materials over this range of usable temperatures, making them a great choice for many applications. Very low temperature capable and extra high temperature stability silicones can be found in our product selection guides.